Hi, thank you for the patience. We had some fun times transporting 3 robots today and fixing some issues on the robots that you never imagined you would get. As always, you know, robot doesn't work at the moment when you need it. So what we want to share with you today is mainly a lot of our open source work that we are working at b-robotized. Basically all the industrial projects, client projects, moving to open source and sharing a few more ideas also then for the later. So first is the question why you are here. Probably you want to get increased performance of your robot, of your industrial applications using ROS2. Then you probably want to know something more about newest developments. Since we are involved a lot of stuff, this will be interesting. Or maybe you are just interested into better collaboration with the community. That's why it will be a lot of open source stuff we are looking on and looking forward to cooperation. And of course, we want to make programming the robots fun. Not as we had today. I mean, we had a lot of fun, to be honest, but you know, always it's nerve-wracking. And why do we do this presentation? Basically, the main thing is at b-robotized that we really believe that robotics is the key for the better life all around the world, because we all know there are many areas where you don't want to put people actually work in. What we saw, ROS2 makes it accessible, and that's why we are deploying it in real-world application and questioning actually, okay, what do we actually need in ROS2? What do we maybe not need, to be honest, and how to apply it at the end in the real-world applications. Shortly about us, we are basically a consulting company or group of companies. We are spread across the Europe. Also the team is across the Europe, and we are helping companies using ROS2 for the new applications, improving applications. There are really different applications, not only industrial ones, but that's one of the things that we are also focusing a lot. I'm the owner and CEO and having PhD in robotics and doing basically, this is continuation of my PhD times when I was building my own robot. Now I help companies to build their own robots and software stacks. And Nikola is the robotics developer. He's from Croatia. That's why the crown on his name. Also, he is ROS2 control contributor and author of multiple driver packages that we'll present today. So first of all, I just want to share, this is my standard slide, why ROS2 control. Basically, most of the things in our work is around ROS2 control, and it's about hardware management and abstraction. We want to have the same access for every robot manufacturer, for every different hardware. We want to basically have the same interfaces, the same access, because this is how our application can scale, and many of the things will be here in this project. And of course, one can ask himself, ROS2 control or NOS2 control. Nevertheless, it always brings you to reuse the hardware drivers, to give you free controllers. There are also a few things that we love a lot, and they are new in ROS2. This is the mock hardware, so literally the best components. I started this idea about mock hardware, and I think it's one of the most simplest and most used components, and I love it because it literally helps you to set up the whole application without even being connected to the hardware. So it really saves a lot of time. So if you want to use ROS, or if you are using ROS2 control, use mock hardware, literally always. It will save you a lot of time. And you want to manage your hardware access. Of course, there are some custom applications when you don't maybe need ROS2 control, but we will show you in this presentation that actually you also then want to have ROS2 control. I just wanted to shortly mention, since I'm one of the maintainers of ROS2 control, we are now the official OSRA project, which means we have all the official things. Actually, this Wednesday is also our meeting. Feel free to join us. I will probably do it before the dinner at ROSCon DE. So you can check the charter, scan everything. You will have also all these links. And there is a bunch of things that I think that people can learn from us in ROS2 control. Not that we are good, but that we made a lot of thoughts about that. And we had a lot of incidents and things, and really thinking how to make open source stack really robust, because more and more really companies and our customers, not only our customers, but other companies rely on it as a hardware interface. And we had few times incidents that we break some behavior during the year, and then this basically disabled a user of ours to not use it. So we did a lot of thoughts about that. That's why we have kind of another date for our stable release, which is basically 1st of October. So now you're on the stable release. Always, we are also doing quite detailed migration guides, so please check it. And what is also very cool, that you can always build the newest version, the newest master version of our repos on all LTEs versions. This helps you literally to use the newest features that you don't even need to backport them, but you can use them from the master branch. And if you are running open source project or thinking to do an open source project, there are also a few things that can save your time. We have some CI templates. Feel free to use them. They are quite good working for us. I hope it works also for your project. It saves your time. You need to have it, but it's annoying to set everything up and maintain it. And I think we figure out now, after 4 years, quite a good setup of CI. Then there is also CMake templates, because there is a lot of repeatable code. We are overtaking more and more repositories in ROS under our maintenance. So we are basically just thinking how to simplify this. Pre-commit is a great thing. I'm pretty much against amend linting stuff, because it's like you really don't want that your testing pipeline explodes if you have one space at the end of the line, which was happening for us, and then have fun scrolling down 15,000 lines in Git logs to figure this out. That's why we use pre-commit, and we don't use amend linting stuff. So definitely one recommendation. And you get then CI pipeline for pre-commit if you want, for free, everything. And our documentation, I put here, I left here Singapore. This was actually also the same slide on the ROSCon, global ROSCon, because I was amazed. If you compare the USA and Singapore and the population of them, Singapore actually has so bigger density of roboticists. I mean, just Ros-control is accessed 5.2 times. And 24.5 times from US. So it's like 50 times more roboticist density in Singapore than US. So congratulations for that. Yeah, it's cool. And what I also wanted to show you, we have open statistics. You can also check it. Everybody can check it. The cool thing is we are really business to business. We are really in business to business market, because you see the weeks exactly in the visits on the website. So this was fun facts to figure out, and some other links that you can find interesting with reference code and so on if you are interested in Ros-control. Just to make this shorter, they were top 5. I cut it because of the sake of the time to top 4 of this summer of Ros-control. Basically, my 4 favorite features. They are newer features and save us so much time for this demo that we are showing also in ROSCon during ROSCon. You will love it. First thing is joint limits enforcement. Now the joint limits are automatically enforced from URDFs. You have additional things. In the newest version, they will always be automatically enforced. Of course, many people wanted to have this for years. Yeah, it's not good that we didn't have that, but we finally have them. And it's important to know that you have them, because this might change behavior of your robot. Then asynchronous hardware components. Now literally, you can run your controllers on different frequencies. So for example, you have here main loop, 500 Hertz, some slow controller, 100 Hertz, and you have different, maybe even blocking hardware interfaces. Then you can run on 50 Hertz or different frequencies. So there are multiple different frequencies. Ros-control gives you infrastructure to synchronize all of those data, so you don't have to play yourself with mutexes and data synchronization, but the framework basically gives it out of the box. And this is kind of connected to the last one, real-time improvements. Now you can really, when you are running real-time kernel, you can, for every of these threads, for every different hardware, you can define the priorities, you can define scheduling with the main thread, and you can define asynchronicity, update rate, and then also here CPU affinity, priority, so you can do a lot of stuff really from your URDF. You don't even need to program for this. Isn't this amazing? You just edit it, restart it, and it works. Very soon you will not even need to restart ROS2 control for it, but this will come. Then diagnostics and introspection, my very favorite topic, literally. If you're running multiple controllers, multiple hardware, use the activity topic. It will save you so much time. You see immediately what is the state of your hardware, you see immediately what is the state of your topic. I just fell in love with it, to be honest. It's actually work of Sai from PAL Robotics, because they have their Talos robot. It's quite complex, a lot of controllers, and they're running 20 to 40 controllers, 40 joints, and all the craziness. And actually, this is what they delivered, and I have to say it's amazing. Even when you're running only one robot with 2 or 3 controllers, you constantly know where you are. Statistics. Amazing thing you get for every hardware component, every controller, read, write, update statistics. When you have issues in your real-time loop, extremely easy to debug. Love it. Just use it in combination with Plot Juggler, and your day is saved. I mean, you can at least better debug. And there are also introspection topics. Basically, now you can see all the data shared between controllers and hardware. Directly, even if non-controller is started, you can see what are the data that your hardware is delivering to you. It's really extremely useful. And now I will give word for Nikola, showing talking about industrial protocols, basically building on top of those things.
Yeah, thanks, Denis. So as Denis said, our goal here is, once you have your application developed, to be as seamless as possible when you actually deploy it on your hardware. For this, we have hardware interfaces, and the devices we interface with talk with through many different protocols, be it CanOpen, Beckhoff, ADS, CtrlX from Rextrot, EtherCAT, very popular, Modbus, the granddad of the protocols, and these are some of the protocols we can now cover with open source hardware interfaces with ROS2 control. So, yeah. That's what I was talking about on the last slide. So we want to have the same interfaces, the same application on top, but have it seamlessly connect to any protocol on the bottom, or to any device using that protocol. So we will do a quick rundown of the protocols we are covering and how ROS2 control fits into them. So we can start with CanOpen. The whole point of our hardware interfaces is ROS2 control currently, which will not be the case for long, only supports double. And most of these protocols and PLCs and other devices have kind of different byte or bit layouts that need to get converted to double. And each of these hardware interfaces is not very smart by itself, but it's a thin transport layer to get it into ROS, to get it to the rest of your application. Okay. Yeah, this is what we want to do basically. So we have written a lot of hardware interfaces ourselves, and from great support of our community have gotten to this list, which is expanding probably as we speak. So first, we have ROS2 CanOpen. CanOpen is a protocol on the CAN bus. It's mostly used in automotive industry. It's generally used with differential drive controllers. It defines, as for the data model, it defines like an object dictionary, and during operation we send either service or process that data objects to update the registers tied to each of these objects. Now we have each of the CanOpen profiles, we have a general specification 301, which defines what process and data objects are and everything, but it doesn't tell you what each of these objects mean. So we generally use CI 402, which is more specific for motors. It's called the motor profile. And we have a hardware interface for this. So if you want to use ROS2 control with motor drives, please buy a motor which is 402 compatible and save yourself a lot of development trouble defining your own objects and words and everything else. So here we have a URDF example. That's about it as to what it takes to connect ROS to your motor. So you define which interface do you want to connect to which index, sub-index. Do you have any scaling? Do you have what is the unit? What is the read-write function? Are we reading a single register, multiple registers, different data types? Here we have a link. You can check out the code, use it yourself. Next, we have Beckhoff ADS. ADS is basically something like TCP/IP, but a little more extended. Each device in the Beckhoff network has its own ADS net ID. And with this hardware interface, ROS2 control becomes a first-grade citizen in the Beckhoff network. So we define the PLC variables we want to connect our state or command interfaces to. We define the PLC types. Some for arrays we need to define if there are multiple elements, some of those details. And usually we have the connection parameters, to which device we are connecting to, what's our AMS-net ID, what's the IP of the device. And now you can kind of see the pattern here. In the configuration of the hardware interface, we have the connection parameters. How do we actually establish our connection? And then we have the definition, how we map our state or command interfaces to the data layout of that specific protocol. Check it out on GitHub, star it, use it, criticize it. That's also important. So next we have the CtrlX DataLayer, which is, if you've used ever controllers from Bosch Rexroth, they have like a central data layer, which is CtrlX is a Linux-based real-time OS, and it gathers all of its apps' shared data into a data layer, which you can refer to each of the variables with almost like a file system. And also we have the IP, the user, the password, and then which interfaces do we connect to which variables. It's important to know that this is not real-time, so this is like a client-server architecture. We also have a real-time hardware interface, but it's not publicly available, as the SDK for the real-time is proprietary still. Next, we have EtherCAT. So the people from iCube Laboratory did this really good package implementing the EtherCAT protocol for ROS2 control. EtherCAT is basically master-slave communication. Master maintains a block of memory called a frame or a process data image, and it sends it around to slaves. Slaves read or write what they need into it and really quickly return it back. In this hardware interface, our hardware interface is, I believe our hardware interface is a master, and then the state and command interfaces refer to different devices they actually represent the actual network you have of the existing devices. And lastly, we have Modbus, which I mentioned is the granddad of protocols, 1970, used since forever in automation. We have 16-bit registers and addresses to refer to them. The master goes around, polls each of the slaves, and updates their state and reads the state. In our hardware interface is a Modbus client. We either connect to an existing Modbus server, or we can also run a Modbus server for testing. And we also define the connection parameters, define how our interface maps to the data. So there are a bunch of caveats to implementations of each of these. I won't get into them right here. Find us later at the social part. And this is actually how ROS-II control is go inch by inch, wiggling its way into the industrial protocols. We've mentioned 5 protocols here. Next year, probably 10. It will be, you will have to have 2 slots for the presentation. Denis, thank you.
Thank you, Nikola. So I would just like to point shortly some other very interesting contributions from our side that you might find useful. There is things for mobile robots that we did together. Also, thank you to Node Robotics from Stuttgart. Basically, we had a project with them. Check our presentation in ROSCon if you know more, but there is battery broadcaster, which is like standard broadcaster now to ROS2 control, where then idea is that you, whatever you have access on your hardware to battery data, you get them standard way out of it for the high-level application, and also VDA5050 Safety State Broadcaster, for example, from your motor, getting safety states out to, again, higher level applications. So these are 2 open PRs. They will be closed quite soon. They are far away. There are some actually bigger discussions popped up and sensor messages repository because we wanted to add new message for this battery broadcaster, but generally this is very, very far away and already used. And also we are working, our just newest colleague was working on the avoiding crashing of ROS2 control when you have errors in your URDF. This is unfortunately what still happens. So there is a PR for it, which bunch of different use cases just to make it more stable. There are other cases where the crashing is still happening. Unfortunately, we are on it and we will just move slowly because I want to have it really nuclear war, so to say, stable, that nothing what flies around as exception can crash it, and your ROS2 control can really run forever if you want. And one of the interesting thing is our presentation of Felix and me on Wednesday. It's about industrial motion primitives. Basically, this was master thesis from one student at our company, and Felix was helping a lot. Felix from UR regarding integration with the robots, give a lot of valuable input. Basically, enables you to control the robot as you usually control it in industry. There is bigger discussion if we need that or not, but let's keep it after the presentation or for today evening. And just as the end, basically, I would just like to shortly mention something that this everything culminated, because one of the questions that drives me, I really love ROS2. I think really that it can contribute, but the question is how do we actually bring it to industry? How do we convince people to actually use it? What is really important to do? Because it's hard to use, let's be honest, it's hard to use. We are all well educated, we are all very good engineers, and it's hard to use. And now it's very beautiful because we were also using some other toolings from companies, Beckhoff, Rexroth, and so on. Actually, their toolings is quite good because it's like stupid proof, you can say. I mean, it's really simple. You want to set EtherCAT network with Rexroth tool, you need 5 minutes. Set it up with ROS. You can reserve the full day for it. Have fun. So these are the things where we have to really improve. And one of our solutions now, it's our product. We call it B-control box. It's basically ROS2 control running on the industrial hardware in the hard real time, just so that people can get their ROS interfaces for their smart solutions that we all love, and on the other hand, to have stable connections with the robot. So they literally don't need to care about it. Currently, we are using for this CtrlX automation platform, as they are very open, very friendly. It's also everything Linux-based, so it was relatively easy. I would put really relatively easy. It took some time to use it, but we are now really running there in the hard real time, and it's so fun because you just start your robot and it works. And not that you, I don't know, start another process and then it crashes, but it's hard real time. You can synchronize with other real-time processes, virtual CPU, EtherCAT connection, and everything. So for us, it's much less headache, and we can much faster come to this part, which is actually what we are all here for. So currently, we have supported KUKA and UR are proven. Also EtherCAT and different I/O models over EtherCAT, this everything works quite nicely. You can also see it on Wednesday, Thursday here at the exhibition, and soon the Franca and Yaskawa will be available. These are basically just robots we are slowly integrating through our projects just to enable simple access to it. And the idea is to have, one controller, multiple robots. You have one application, you can simply use it on many different robots. Just to give you, as you are most of you technical people, just to give you some feeling what we are talking about. We are talking also about devices of different sizes. Really, the small device, it's very attractive on the price level when you think how much time you spend developing those stuff and setting up your real-time kernel and all those funky things. This is definitely financially and economically more better solution, to be honest. And you see some different sizes depending what you want to run. I mean, we are now mostly using X7 because it's ARM, because it's AMD architecture. For us, it's very easy to deploy application, much easier than on the ARM architecture, because we are going under operating system basically with our setup. This is the reason, but this thing is bored. I mean, we will have here demo with multiple robots, and this thing doesn't know what to do because it's like CPU, it's 10% or something like that. And we are really running, we are running application. Actually, that school, Ros-controls, managed to run about 60 microseconds we need for all the control loop with joint trajectory broadcast and everything. So you see how those things are actually then very cool working. If you're interested, let's talk. Looking also forward to talk with you later at the dinner. At least exchange or comment. Maybe you have some other ideas. So this is where we came up with. Thank you very much. I hope we managed to provide some values, new ideas, and I hope many discussions can be opened after this presentation. So the question is the CanOpen driver also possible to use to other devices than div drive, typical mobile robot application? Yes. Oftentimes people are, of course, using it because CAN is very, very widespread in the mobile robotics. But generally, yes, currently you have 301 and 402 profiles fully implemented. I mean, fully, as much as you might need, also with error handlings and stuff like that. Actually, the guys from IPA are main maintainers of it. We are more looking on the Ros-controls side and connecting to it. I don't know, with other profiles, you would need to implement it if you need some specific profile, but basically with 301, you have, it's like typical I/O profile, so you can model anything. And what Nikola showed you here, you basically say, I want to name this interface to the address. You map Ros-controls specific interface to the address of the CanOpen, and they are then connected. So how you call them and how you then use them with which controller, you can easily use it with ARMs. If you have then 6 joints, you can use joint trajectory controller. Yeah, I mean, this thing is not hardware. This is basically software stack for CAN. So you need always your PIC to USB, PIC PCI, or something else. Yeah.
You said that you migrated to the CtrlX. I think Rexroth itself provides a ROS-2 interface. What's the difference between your migration and Rexroth's software module?
I mean, they provide ROS-2 examples. They are nice, but they know exactly that they are not useful at all. No, I mean, who cares about publisher-listener example? Nobody. I think nobody cares in this room because it's like, okay, nice, I can do anything with that. Basically, what we provide, they have also set up how to do non-real-time applications. What we have actually here, and this is the hard part, that's why we kind of productize it to maintain it properly over years as industrial product to give really long-term support for it. It's the real time. So we are really going in the hard real time and so on. I mean, non-real time data layer connection to Ros-controls you get also from us as open source. But hard real time, it's another kind of firms. You're welcome.